on that one.
We call that the black card.
Because
Morgan Freeman.
remember, this is an open microphone. Recording class.
It's recorded? All right, everyone.
Every day.
Hugs and bubbles.
Every day it records class. Because this is the first time I go through this class.
All right,
So I record every day.
Guys, this whole row, we're gonna go a whole period without talking. Why are you laughing?
I never said we didn't need to talk. Like we gonna be talking.
All right.
It's all good. We okay to talk. We just gotta be focused. Superhero choices are not it. Okay. So these are kind of weird and kind of awkward. They don't feel like we're making things better. Things sometimes look worse. We're going to be working with things called literal equations. They're called literal equations literally because they use literal letters. Like literature is made up of words. Literal equations are made of letters. That's why they're called that. Just weird. So on these, we're not going to necessarily get an answer. Our answer is going to look like an equation. And it's kind of icky. So we're going to try, at least we're going to do the first one together for sure, and then I'm going to give you some time to look at 2 and 3 and see what we can come up with. 4 and 5 are challenge mode. So we're going to give these a go. Or I guess A, B, and C. What else? So if we wanted to take A and do what it says, is to solve for H. What that means is I want this to be H equals. We have A equals HW. I want the H by itself. What do I need to do? Divide by what? Because you're right. We are going to need to divide. Put it on here. Because what we have here is A equals HW. What does it mean when they're smashed together like that, H and W? What does it mean when they're smashed together? Add, subtract, multiply, divide to a power. What do we think instead of just juggling invisible stuff? I don't know why we're sitting here in invisible juggling. Yeah, use your words. Throw a marker right here. Words. What do we do? What does it mean when they're pressed against each other like that? What's happening between the H and the W?
H equals W over A.
Almost.
A over W.
Because when they're pressed right against each other, that means they're being multiplied. That's H times W. So if I want the H all by itself, I need to get rid of that W. And the way we undo multiplication is by dividing. So there my W's cancel out. That's the whole point we have for doing that. I wanted to get rid of those W's. So we have an H all by itself on this side. And the left-hand side kind of looks gross. A over W. There's not anything we can do to simplify that. There's not anything I can do to change it around. I could make it be H equals and just flip it on the other side, but that's about all I could do. I could do H equals A over W. But that's what our answer would be. We're not getting an actual number. We're not getting a single answer. It kind of looks like an equation. So see what we can do for B. At the very least, see what we can do for B. See if we can get that one to be a W equals. Because this is our whole answer on this guy. That's A. Done. That's all we can do. See what we can do for B. See if we can come up with something. See if we can get that to be a W equals. How would we do that? Give it a try. And you guys can talk to each other. Might help to have a book to write in. Or paper. Good shot. What we got? what we can come up with. You don't need to worry about what they do. Plenty of look. We've got plenty of space to write it too. Page looks like this. We've got lots of space. So much space. See what we can come up with this one. It says solve for W. That means we would really like this to be W equals or something equals W. See if we can get that. So what would we do first on this one? How could we get this to be W equals on B? What do we need to do first? I want this guy by himself. What do we need to do first? You can, but that's going to give you fractions earlier on if you divide early. Okay, dude, you tall enough as it is. There you go. Thank you. I was like, you can. Absolutely, Roman. If you want to divide by 2 first, you totally can. It's just going to give you fractions early on if we start with the dividing. If we are not sure where to start, if we're not sure where to start, normally we think about simplifying. That would be our not crossing the equal sign. We go PEMDAS. So if we're simplifying, we go this way. If we are solving and we don't know where to start, go backwards. Solving, a great option is to go this way. It's not a you have to do it. It is not a you must do it in this order kind of situation. But if we're not sure what to start with things that are being added or subtracted. So if I would like to get my W by itself, what should we maybe look at first? Subtracting. I have a piece that's being added onto it. I've got 2W plus something else. I want to get rid of that something else. So if it's being added on, let's subtract this 2H. Can I combine together the P and the 2H into one thing? That's that I have a pony and I'm going to take away 2 horseshoes. Not the same thing. My ponies and horseshoes are separated. Granted, they're related, but they are not the same thing. Minus 2H equals our 2W. Still looking to get that W by itself. Now what will it do? Divide by 2. So I'm just dancing to the music that I can hear from up here. We can divide this by 2. We can do the whole thing and divide by 2. Or you can divide each piece. Since we don't really have an answer we're looking for here, we can leave it as the big gargantua fraction. Totally fine. Or you can break it apart and divide then 2. So we're going to get this kind of really ugly fraction that I'm just going to write over here. I'm going to write over here. So we get this P minus 2H all over 2 equals our W. That is 100% an okay answer. If we divide it by first, it might be slightly different. So if you got P over 2 minus H, that also equals W, it's totally fine. If you do them in different orders, you might wind up with a slightly different statement, but they are equivalent. They mean the same thing. If I substituted numbers in for P or H or W, I'd get the exact same answers. So either one of these would work totally fine. And I don't care which one we have. Whichever one of these makes your head hurt less. If you do it as one big fraction or as two little fractions. Both are totally fine. So these both would totally count as our answers. This one's fine, and this one's fine. Our third one on here, C, we're trying to get H by itself. I'm going to change my view real quick. See what we can come up with for H. We want to, or for C, we want to get H by itself. Solve for H. See what we can come up with. These are all formulas you have used before. They're all geometry formulas, actually. First one is area of a rectangle, height times width. Then we had a perimeter, 2 times the width, 2 times the height. This one here is a volume, pi r squared h. That'd be volume of a cylinder. So this is saying, how could we get h by itself? If I know the volume and I know the radius, how could I solve for height? See what we can come up with. I don't know what that does. It looks like a quarter note. Like a quarter note rest. I don't know what you're trying to draw. Do I need a square root? What are we looking for? I just want him. I don't care about anybody else. Is h squared? That square in there will throw everybody, will throw us off. Think of pi is just a number. R squared, just a number. What is happening between the pi r squared and the h? Addition, subtraction, multiplication, power, something weird. What's going on right here? Oop. Yeah, this is the volume of a cylinder. This is just being times. The r is the only thing being squared. So the square is not touching the h at all. It's just that we have r squared and then h, separate. So if pi and r squared are both being timesed against h, how do I get rid of them? How do we undo multiplication?
Divide.
We're going to divide.
Square root, no, you're just trying to find R, so I don't think having the square root would matter too much.
Square root doesn't matter too much. I just need this r squared to leave. If I divide by r squared, that guy's going to go away. But whenever I divide by something, I got to do the same thing to the other side. What else needs to divide away to get my h by itself? The pi. Even though there's pi's and r's and squares and all kinds of weird stuff in here, those are being multiplied against my h. I don't have to get r by itself. That's when we would need a square root. So if I want my h by itself, I divide by my r squared, so that guy cancels out. I divided by pi, so that guy cancels out. And we have just our h left. So on this side, we get v over pi r squared. If things are being multiplied, we use division to undo them. If things are being added or subtracted, we use added and subtract and get rid of them. We don't have any terms here where we're going to have a square on them just because we're not talking about square roots right now. As far as we're concerned, r squared, we already know that, so maybe it was 3 squared. So the r squared really is just going to say 9. If r is 2, r squared is just going to be 4. It's just going to be a number. Sometimes we do want to actually solve equations to equal a different letter. A lot of times that'll happen if we have super icky formulas, and there's formulas that are super long and kind of gross, and they have to do this kind of stuff, and things like air traffic control. They have lots of equations they have to use where they have to substitute in lots of different variables very, very quickly. So they will have the formulas pre-worked out and just have to substitute pieces in. Well, if we know altitude and I know their distance, this is how fast they need to be going. If I know they're going this fast and they're this far away, here's where they need to get for their altitude. So they have all kinds of different pieces they have to work out. And sometimes solving for a different letter really does help us get where we need to be. So we're going to work 2 more of them because part D has an important piece that we need to see in it. And E is kind of gross, but we're going to look at it anyway. So D has a really funky piece in it. And it's something we're not going to see super often, but it is something that does happen. This one is a physics thing. And it's that little baby 0 that's underneath the V. It looks like VOT. This is a form of a velocity of equation. We've got velocity and time and acceleration and time. So it's a physics thing. The way we read these little like sub numbers under here, this is one chunk. This is V with a little 0 at the bottom. That is V naught, N-A-U-G-H-T, meaning 0, or the first time, or at the start. It's like if you've ever been into like photomath, I'm sure we've never used that, or any of those kinds of things, where they give you like your answer as x1 or x2. This is just V0, V naught. It's where it's starting. It is the velocity at the moment we start. So when they have these little baby numbers at the bottom, it means at the start for a 0, or the first one, or the second one. It's not a huge deal. We're not going to have tons of things to do with them, but if we see them, that's what they are. They show up occasionally. We might see 1 or 2 a chapter tops, and it's really when they start pulling in physics stuff. So it's not a different term. It's just a guy. You can call him V. He's just V naught. It's like his last name. He just always goes by full name. So this is how those are. On this one, we're wanting to get A by itself. So we're trying to solve for A here. So we want A equals or something equals A. Don't, as I say, I'm drawing on that. You love to draw on that clipboard. Oh my goodness. Really hard, so it makes the squeaky noise like a chalkboard. So if we want to solve for A, what do we need to do first? What should we start with? If I want to get this piece all by itself. This is what I want. I want this piece to be all by itself. I like when somebody sarcastically goes down a slide really, really slow. I just watch K-pop Demon Hunters. They do that at the beginning when they go down the slide and go, yeah, it's giving that. Let's do this. Stop sliding down the slide in a leather outfit. That's what it sounds like. What should we do first? That's just one thing. I want the A by itself. I'm going to keep that deleted. How about you use your words? I I want to do that first. You can do that, but it's not going to be pleasant. When in doubt. What is being added or subtracted to A? Start with things being added or subtracted. Is that things being added or subtracted? You're asking the thing at the bottom. Would y'all just use words? It just means it is a thing. V naught just means V, just at a very specific spot. It's talking about velocity. That would be your velocity at go. So we think about, just 1 second. So if you think about, Joseph, you think about Indy cars, like race cars, when they do that and they do the pace laps and they're getting up to speed, when they get that green flag and go, that's their V naught. That is their initial velocity. It's just talking about it at the start. It's not going to be a thing we need to know off the top of our head. It's a physics thing, but like they just like to throw those in for us. Fun times. My question remains, what is being added or subtracted to the thing that has the A? Is that being added or subtracted? Or is that being multiplied? So what's being added or subtracted? That guy is being added or subtracted. If I want the A by itself, it's going to be the least amount of fractiony grossness if we do our adding and subtracting first. If you just start dividing, you're going to have fractions everywhere. So I understand the impulse to start dividing. I'm just going to get rid of this guy. But I really would rather subtract this V naught T. Just that guy. I'm trying to think of a celebrity who's I don't know how like Madonna just goes by Madonna. But if you call Rachel Ray just Rachel, it sounds wrong. Because she's always Rachel Ray. V naught is Rachel Ray. T is Madonna. V naught is just, you always have to use all the whole name. That's all he is. He's just a little extra. V naught T. I'm sure there's a sports player that has a similar reference. But I don't know one off the top of my head.
John Cena.
Yeah, no one just calls him John. I mean, I'm sure his family does. But John Cena, everyone just calls him John Cena. Whereas Kobe Bryant, people will just call him Kobe, so he could be T. Because he's Kobe. It's just Kobe. So this, I can't combine my H and my V naught T. They're separate pieces. They're just going to go next to each other. But this cancels that guy out. So all we have left over here is our 1/2 A T squared. I still want that A by itself. We have 2 options of things we can do to get A by itself right here. 3 options, but one of them is really unpleasant. What could we do here to get my A by itself? I'll zoom it in because I know it feels really small up there. It doesn't matter what's on this side. This side can get really, really gross. So just look over here. What can I do to get this A by itself? Stop trying to square root stuff. We don't need to square root. Not until we start dealing with exponents ourselves. T squared is just a big number. Because that square is just for the T, so he's not sharing his power. He holds it. He's not sharing. He says, I am square and no one else is square. You don't have to square root. He's just on the T. So what do I need to do? How can I get the A by itself? Whenever we see a fraction and we go, ew, gross fractions, how can I get rid of a denominator? Multiply. I don't know why we're playing this silent game today. So I have a denominator of 2. If I want to get rid of that fraction because, ew, fractions are gross, I would multiply this side by 2. That would make those 2 pieces cancel out. But if I multiply the right-hand side by 2, I need to multiply this side by 2. multiply. We can leave it in parentheses or we can distribute it out. I'm 100% okay with it either way. I'm just going to write this up over here because I'm going to run out of space. So we're going to have our 2 with our h minus v naught t equals our a t squared. Still want my a by itself. We're almost there. One thing left. Divide by t squared. I want to get rid of that t squared, and t squared is pressed right up against the a. That means they're being multiplied. So to get rid of it, I have to divide. So our a, all by itself now, yay, is this hot mess of a fraction. 2 times our h minus v naught t over t squared. I've got my a all by itself. That's all I need to do. The left-hand side can be messy. It can be a hot mess. And this is a hot mess. It really is. This is gross. But it is really handy to be able to solve for a certain kind of letter, because if I knew I was going to need to figure out what A was each time, it's a lot easier to substitute pieces in like this than to have to solve it all the way out every single time. So sometimes we have to be able to simplify it when it's got letters in it and things like that. Let's look at the bottom one, E. This will be our last one for today. And it's a little icky looking. We're wanting to solve for y. We're trying to get a y equals here. And the first thing I notice on this is, ew, fractions, gross. How do we get rid of a fraction? Multiply by the denominator. If I multiply both sides by that denominator, whoop, my screen is freaking out on me. There we go. Where we have our, I'm just going to rewrite the whole thing down here so I have space. 2xy minus 7 over our 3xy plus 8 equals 1. And I multiply this side by that denominator, 3xy plus 8. And I multiply this side by 3xy plus 8. The benefit of doing that is this guy and that guy cancel out entirely. Gone. And then we have pieces that are at least not fractiony. I've got my 2xy minus 7. And that is going to be equal to my 3xy plus 8. How could I try and get a y equals here? What would we need to do to try and get to a y? We could add 7. Yeah, let's go ahead. Let's add 7 to both sides. That's going to give me my 2xy equals 3xy plus 15. Totally fine. We can do that. Super duper close. Danger on that is that I have x's on both sides. What should we try and do first? Let's get our x's, our xy's at least, on the same side of the equal sign. Because I have 2 funny looking things and 3 funny looking things. So if I at least get those onto the same side of the equal sign. So I'm going to subtract this 3xy from this side. Because then this guy's going to cancel out. We like that. And we have just a 15 over here. If I have 2xy, take away 3xy, what are we left with? What do we have? Can I smush these together? What do you think? Can we combine them together? Yeah. I have 2 weird looking things. And I'm going to take away 3 weird looking things. We're going to get minus 1 xy. Totally valid. If they have the exact same letters, I can just subtract the numbers. 2 minus 3 minus 1. We want to get that y by itself, so what do we need to do to get my y by itself? We're going to divide by the minus 1x. Divide by the minus 1x. That's going to give me just my y equals, and you can have it be 15 over minus x or minus 1x. Negative 15 over x, negative 15 over x. Wherever you put the negative sign, it doesn't matter. I could write this as negative 15 over x. It still means the same thing. Or I could do minus 15 over x. All of those work and all of those are equivalent. Okay? So when we're working with equations and we're trying to solve things around, they're not always going to be pretty. Sometimes they are going to be an absolute mess. And that's okay. We are not going to have tons and tons and tons of these, though that is what homework 3 has on it. Has several of these, and it has questions like the cars from yesterday. So, homework 3 is what we should work on. We have about 7 minutes left. So you guys could start working on that. If you started working on it yesterday, you should still be able to pull it up. Like, it'll have all those up. And then I think we only have one more homework after that for this chapter, because our chapter test is next week. In fact, I believe it is next Friday. Yes, next Friday.